Okay, let me finish this thing. Okay. All right, so, oops, I can't do it there. I have to do it over here. It might end up being too big, but okay, first you find your oxidation numbers, split it into your half reactions. All right, I'm just writing out the 10 steps. I'm going to keep them up here this whole time while I'm doing the thing. That's everything but hydrogen. Oxygen, oops, not balance, balance. Oh, I can't do subscripts. All right, well, don't need subscripts. Okay, so now let's make it a little bit smaller so it all fits on the screen. All right. Let's see. Can I resize it? Oh, don't do that. All right, just leave it as it is. Okay, so we're going to balance some redox reactions, and I'm going to go a little bit overboard, a little bit overboard, and also do the oxidation numbers. Okay. So what am I looking for? This is what I'm looking for here. Bang. All right, so hopefully you haven't already seen these. Now, what I recommend is, as I work through these, you go ahead, you wait for me to finish writing out the example problem, and then you pause the video, try to balance it yourself, and then come back and watch me work through it. All right, so first up, chromium 3 hydroxide plus bromine goes to chromate plus bromide. All right, so hydrogen is +1, oxygen is -2, oxygen here is -2, bromine is a native element, so it's 0, chromium is +3 over here, chromium is 6+, bromine is -1. Okay, so that means that bromine is being reduced and chromium is being oxidized. So, split it into our redox and oxidation half reactions. So, CrOH3 is going to become CrO4 2 minus. Let's go ahead and just balance this one all the way through. Chromium is already balanced. We balance oxygen by adding water. We have 4 oxygens here. We have 3 over here, so we need 1 more water. Now we balance hydrogens by adding H+. We have 5 hydrogens, so we need 5 H+. And at a balanced charge, we have 0 and 0, -2 and +5. So there's +3 on the left, 0 on the right. Let's go ahead and make that kind of explicit. 0 and 0 adds up to 0. -2, +5 adds up to +3. So that means we need 3 electrons on the right. And you'll notice that that works perfectly because we have 1 chromium going from +3 to +6. It is losing 3 electrons, so that's where they end up. My dog and my cat are going nuts. All right, now our oxidation half reaction is bromine turning into bromide. So now we need 2 of these, and no hydrogen, no oxygen. All we need is 2 electrons to balance out the difference in charge. Let me just double check, make sure you all can see what I'm doing. You can, and you can hear me. Excellent. Okay, so now we need to balance our 2 reactions against each other. We need to make these electrons disappear. So we multiply everything down here by 3, multiply everything by up here by 2. So there's going to be 2, 2, 2. 2 times 5 makes 10. 2 times 3 makes 6. Everything down here is getting multiplied by 3. So 3, 6, and 6. And now let's go ahead and cancel out everything that appears on both sides of the arrows. So our 6 electrons are going to cancel out, and that's it. So now we can add our 2 half reactions together. So 2CrOH3 plus 3Br2 plus 2H2O yields 2CrO4 2 minus plus 6Br minus plus 10H plus. And let's see, this one is in basic solution. I should have mentioned that up top. Base. So we need to cancel out the H plus by adding OH minus to either side. So we add 10 OH minus, we add 10 OH minus, but we know from our acid-base neutralizations that H plus OH minus yields H2O. So now we have 10 water on the right, we have 2 water on the left. These 2 water cancel out, and this 10 drops down to 8. So once again, rejiggering our reaction, it's 2CrOH3 plus 3Br2 plus 10 OH minus yields 2CrO4 2 minus plus 6Br minus plus 8H2O. And now, to double check, chromium, oxygen, hydrogen, bromine, and charge. 2 chromium on the left versus 2 chromium on the right. Oxygen, 2 times 3 is 6, plus 10 is 16 oxygen on the left. On the right, we have 2 times 4 is 8, 8 times 1 is 8, 8 plus 8 is 16. So those both check out. Hydrogen, 2 times 3 is 6, plus 10 makes 16 hydrogens on the left. 8 times 2 is 16 hydrogens on the right. 3 times 2 makes 6 bromine. 6 times 1 makes 6 bromine. As for charge, we have 0, 0, and -10. Over here we have -4, -6, and 0. So it's -10 on both sides. And then we also have to double check the coefficients, make sure we have them in our 2 and 3. We can't possibly reduce this any further. All right. So that is that reaction balanced in a base. Let's move on to the next problem. I have 8 problems I'm going to work through here. So this is probably going to take me a good hour. Okay. So next up, another one in base. Oxygen plus antimony yields hydrogen peroxide and SbO2 1 minus. Antimonite, maybe? Okay. Well, oxygen is 0 over here, native element. Antimony is also 0. Here we have +1, -1 for hydrogen and oxygen. Meanwhile, this oxygen is -2, and antimony is +3. All right, so this one, and it's in base. All right, so this one looks really confusing because oxygen is going from 0 to 2 different things. If you were to get something like this, which probably not, well, we can state confidently that the antimony is being reduced. We can also state confidently, or sorry, dang it. I looked at the red color, got confused. The antimony is being oxidized. It's going up from 0 to +3. Meanwhile, oxygen, no matter what, it's being reduced. But what you should do is use the SbO2 1 minus in the oxidation half reaction because the antimony is being oxidized. Use the hydrogen peroxide in the reduction half reaction. Don't worry about the oxygen that's there. That will be taken care of by the normal balancing of the redox reaction. So reduction is our oxygen. So O2 going to H2O2. We balance everything but hydrogen and oxygen. It's now balanced. Balance oxygen, well, that's also balanced. We don't need to add anything. So now we just add 2H plus on the left to balance out the hydrogens, and then we have to add 2 electrons to balance out the charge. Now we come down to our oxidation half reaction. Our antimony going to SbO2 1 minus. Antimony is balanced. We balance oxygen by adding water. We balance hydrogen by adding H+. Now we balance charge. We're going to need 3 electrons here. And now we balance everything so the electrons disappear. We're going to multiply the top reaction by 3. We're going to multiply the oxidation half reaction by 2. 3 oxygen, 6 hydrogen, 6 electrons, 3 peroxides, 2 antimony, 4 water, 2 antimonites, 8 hydrogens, and 6 electrons. Let's go ahead and cancel. We have no water to balance out. We have 8 versus 6, so the 6 hydrogens will disappear and we'll be left with 2. 8 minus 6 is 2. And of course our electrons disappear completely. Which leaves us with 3 oxygen plus 2 antimony plus 4 H2O yields 3 H2O2 plus 2 SbO2 1 minus plus 2 H plus. This is in base, so we have to add hydroxides. 2 OH minus, 2 OH minus. We're going to end up with 2 water. 4 water minus 2 leaves us with 2, and that cancels out entirely. So 3 O2 plus 2 SB plus 2 H2O plus 2 OH minus yields 3 H2O2 plus 2 SbO2 1 minus. Double check our elements. We have antimony, hydrogen, oxygen, and charge. And let's go ahead and put coefficients in there to be double checked as well. 2 antimony on the left, 2 antimony on the right. 4 plus 2 makes 6 hydrogen on the left, 6 hydrogen on the right. 2 plus 2 is 4, plus 6 makes 10 oxygens. 3 times 2 is 6. 2 times 2 is 4. We have 10 oxygens on the right. On the left, we have a -2 charge, 0, 0, 0, -2. On the right, we have 0 and -10, -2 charge. As for numbers, 3, 2, 2, 2, 3, 2, yeah, there's no way to balance that. So that is the reaction of oxygen and antimony in a basic solution. Next up, our first acid problem, HCOOH. That would be formaldehyde. No, it wouldn't. That'd be formic acid. HCOOH plus MnO4, 1 minus, yields CO2 plus Mn2 plus in acid. Okay, so our manganese is going from +7 to +2. Our carbon, I think that's going from +3 to +4. Yes. No. Yes. +3 to +4. That's a difficult one in terms of the redoxing. But yeah, it's going from... Actually, it might be +2. Let me think. Yeah. Nope, +3. Oof. Anyway. Regardless, it'll all work out. So this is our reduction, so let's go ahead and do our reduction half reaction. MnO4 1 minus going to Mn2 plus. Our manganese is already balanced. We balance our oxygen by adding 4 waters. We're going to balance our hydrogen with 8H plus. Now we have 7 plus on the left. We have 2 plus on the right. We need 5 electrons. Okay, now oxidation, HCOOH going to CO2, 1 carbon, we have 2 oxygens, so we just need 2H plus and 2E minus. So, yeah, I was right the second time. It's +2. All right. So, now we balance our two half reactions against each other so that our electrons will disappear. We need to multiply this by 5. We need to multiply this by 2. So 2, 16, 10, 2, and 8, 5, 5, 10, and 10. So now, let's see, 10H versus 16. We're going to be left with 6 hydrogens. And our 10 electrons cancel, and we don't touch the water. So it is 2MnO4 1 minus plus 5HCOOH plus 6H plus yields 5CO2 plus 2Mn2 plus 8H2O. So now we have manganese, oxygen, carbon, and hydrogen. So 2 manganese on the left, 2 manganese on the right. Oh. This was an acid, so I didn't have to balance anything else. Let's see, 2 times 4 is 8, and then 5 times 2 is 10, so we have 18 oxygens on the left. 5 times 2 is 10, plus 8 is 18 oxygens on the right. 5 carbon on the left, 5 carbon on the right. Hydrogen, 10 plus 6 is 16. 8 times 2 is 16. For charge, we have -2, 0, and +6. Over here we have 0, +4, and 0. So it's +4 on both sides. Coefficients 2, 5, 6, 5, 2, 8. Yep, there's no way to break down the coefficients. All right, so that is manganate. No, sorry, permanganate plus formic acid in an acidic solution, yielding carbon dioxide and manganese 2. Okay, then. So that's that one. Okay. Now we have chlorite going to chlorine dioxide and chloride in an acid solution. ClO2, 1 minus, going to ClO2 plus Cl minus. All right, this one will look especially confusing, but let's see. Chlorine is going from +3, oxygen is -2. Here, chlorine is -1, oxygen is still -2, and this chlorine is +4. So you're going to get multiple chlorides reacting with one another to produce chlorine dioxide and chloride. So some of the chlorines will be reduced and some of them will be oxidized. So this is reduced and oxidized. So that's not a problem. You just put it in the reactant side of both of your half reactions. And what's changing is the products. All right, so the chlorines are all balanced. Oxygen is balanced up here. Oxygen is not balanced down here. We need 2H2O, which means we need 2H plus, no, sorry, 4H plus on this side, which means we need 3 electrons there, and we need 1 electron here. So in order to balance the two reactions against each other, we just need to multiply this guy by 3. So 3, 3, and 3. The electrons are the only things that will get canceled. Oh, and this was in acid. Okay, so that means that our balanced reaction is 4 of our chlorides, ClO2 1 minus, plus 4H plus, yields 3 ClO2 plus Cl minus plus 2 H2O. All right, so basically 4 of these chlorites come together. They interact such that 3 of them hand over electrons to the chloride. Okay. Okay, and as for balancing, we have 4 chlorine, 3 plus 1 makes 4, 8 oxygen, 6 plus 2 makes 8, 4 hydrogen, 2 times 2 is 4, charge, -4, +4 makes 0. Uh-oh. Oh. I done screwed up. Because this should not be 3 electrons, this should be 5. Okay, I'm going to start this over. I made a mistake. Okay, so it's ClO2 minus going to form ClO2 plus E minus. That one I got entirely correct. It was this one, ClO2 minus going to form Cl minus plus 2H2O plus 4H plus. I got that exactly right, but wait, we need 4 electrons there, not 3. So then we come through and we multiply the top guy by 4 to cancel out those electrons. So we're getting at 5 ClO2 minus plus 4 H plus goes to 4 ClO2 plus Cl minus plus 2 H2O. Okay, now it should balance out. 5, 4 plus 1 is 5 chlorines, 10 oxygen, 8 plus 2 makes 10 oxygen, 4 hydrogen, 2 times 2 is 4 hydrogen. And then as for charge, -5 and +4 makes -1 versus -1. So now charge is balanced. See, this is why you always double check. Even after, 20 years of this, you can still make mistakes. All right, and then our coefficients, 5, 4, 4, 1, 2. Yeah, there's no common factor. We can't divide by anything. So that's that guy balanced in an acid solution. Okay, next up. Nickel dioxide plus 2H2O plus iron. NiO2 plus 2H2O plus Fe yields nickel 2 hydroxide plus iron 2 hydroxide in base. All right, so here nickel is +4, iron is 0, nickel is now +2, and the iron is +2. So the iron is being oxidized, the nickel is being reduced. Yes, I did not even once consider hydrogen or oxygen in there. That's not to say hydrogen and oxygen can't change their oxidation numbers. It's just that in this case, it was so obvious that it was the nickel and the iron. Okay, so our reduction half reaction. NiO2 to NiOH2. The nickel is balanced. We have 2 oxygens, so we just need 2 hydrogens, and then we balance the charge with 2 electrons. Oxide, or oxidation, iron goes to FeOH2. Iron is balanced. We need 2 waters to balance the oxygens. We're going to need 2 H plus over here to balance the hydrogens. 2 times 2 is 4. We only had 2. And 2 electrons. Oh, and we don't even need to multiply by anything in order to balance stuff out, because we have 2 electrons there and 2 electrons there. So H plus cancels, E minus cancels. Oh, and that just leaves us with what we had at the top. They've already given us the balanced reactions. Okay, so I'm going to... Oh, wait, no, well, it's in base, but that doesn't matter because there's no H plus to cancel out. So it's just NiO2 plus Fe plus 2H2O, NiOH2 plus FeOH2. Well, that's boring. Oh, okay, I'm going to be more careful with the next problem. I'm going to choose one that's not already balanced. It's no fun to have the answer already. Okay. So now we have carbon dioxide plus NH2OH. Interesting. Don't know what that is. Going to carbon monoxide and nitrogen. All right, so carbon here is +4. Carbon here is +2. The nitrogen here, well, it's starting at 0. Interesting. How would I call that? Well, remember, that would be -2. I don't know what I would call that. -1. Maybe those would be even. I don't know. Well, it's going to have to be positive, right? No, because we have the hydrogens there. So I'm just going to go ahead and call this -1. I don't know. That's a weird one for me. I'm not accustomed to thinking about these for compounds like this. It's not the way I normally think about oxidation numbers. Well, I mean, let's see. Our hydrogen's +1, +1, -2, +1. So in order to balance all that out, 1, 2, 3, and -2, you're going to need a -1. Yeah, so -1. All right. So our reduction half reaction is our CO2 going to form CO. So we're going to need water over here, which means we need 2 hydrogens. And let's see, what is this? This is in base. So we're also going to need 2 electrons. Oxidation, NH2OH to N2. We're going to need 2 of these to balance out the nitrogens. We have 2 oxygens, so we're going to need 2 waters. Now we have 6 hydrogen on the left and 4 on the right, so we're going to need 2H plus 2E minus. Ran out of room. All right, so once again, our electrons are already balanced, so we're not going to need to do anything too fancy there. Our H pluses cancel, and our E minuses cancel. And that leaves us with CO2 plus 2 NH2OH yields carbon monoxide plus nitrogen plus 3H2O. That's different. Okay, charge is obviously the charge is balanced because everything's neutral here. Obviously our coefficients can't get any more reduced. We have some 1s. All right, so 1 carbon, 2 nitrogen, 2 nitrogen, 1, 2, 3, 4 oxygen, 1, 2, 3, 4 oxygen, and then 6 hydrogen, 6 hydrogen. All right, everything is balanced. And we don't need to change anything, even though it's in base, because all of our H pluses canceled out. So we don't need to do anything. It would be the same base or acid. Nifty. Okay, next up. Hydrogen peroxide plus iron 2 plus goes to iron 3 plus water. So here our oxygen is -1, here our oxygen is -2. Here our iron is +2, here our iron is +3. So our oxygen is being reduced, our iron is being oxidized. So our reduction half reaction, H2O2 goes to H2O. So we balance our oxygens by bringing in another water. But now we need 2H plus 2E minus on the reactant side. Our oxidation is Fe2 plus going to Fe3 plus. So the iron is balanced. There's no oxygen, there's no hydrogen. All we do is balance the charge by adding an electron. So now we balance the two reactions against each other so that our electrons disappear, which they dutifully do. Oh, and is this an acid or base? This is an acid. So now, when we add our two half reactions together, we have 2Fe2 plus H2O2 plus 2H plus yields 2Fe3 plus 2H2O. Yet can't reduce the numbers anymore. 6 plus 4 plus 2 makes 6 plus 2 irons, 4 and 4 hydrogens, 2 oxygens, 2 oxygens. Everything checks out. All right. One more. Wow, I plowed through these. I did not think I would get through this. And wow. All right. So next up we have I'm going to need more room. MnO4 minus plus sulfur dioxide yields Mn2 plus HSO4 1 minus in acid. So manganese is going from +7 to +2. Sulfur is going from +4 to, I think it's +6. Yes, +6. -2 is -8. This guy is +1. 1 minus 8 plus x equals -1. So x equals +6. Okay. So our sulfur is being oxidized, our manganese is being reduced. So reduction half reaction, MnO4 minus going to Mn2 plus. We balance, okay, manganese is balanced, so we add our 4 waters, 8 hydrogens. So +7 out of +2, we need 5 electrons. All right. Oxidation. SO2. HSO4, 1 minus. We need 2 waters. 4 hydrogen versus 1 hydrogen. We need 3 hydrogen. And to balance the charge, neutral, -1, +3, we need 2 electrons there. So in order to balance these out, we're going to multiply this guy by 2 and this one by 5. So 2, 16, 10, 2, and 8, 5, 10, 5, 15, and 10. So now we cancel. We have 15 hydrogens here. We have 16 here. We're going to be left with 1. Our 10 electrons cancel out. We have 8 water versus 10. We're going to be left with 2. So 2 permanganates plus 5 of our sulfur dioxide plus 2 H2O yields 2 Mn2 plus 5 HSO4 1 minus plus, oh, I forgot H plus here on the left. Yes, okay. And this is taking place in acid, so I don't need to do the OH minus thing. Okay, so coefficients are fine. We have 2s and 5s. Oh, and a 1, so there's nothing to reduce. What about charge? -2, 0, 0, +1, so it's going to be -1 on the left. 4 plus, 5 minus, it's going to be -1 on the right. Excellent. 2 manganese, 2 manganese, 5 sulfur, 5 sulfur. 8 oxygens plus 10 makes 18, plus 2 is 20 oxygens. 5 times 4 is 20 oxygens. And hydrogens, we have 1 plus 4 makes 5, and then we have 5 there on the right. All right, everything checks out. Okay, so those are just 8 more examples of redox reactions. I'm able to fly through those because I've had just so much practice. But even then, you'll notice that I still made a mistake. So be careful with these things. They will bite you in the keister. Go ahead and get lots and lots of practice. You can do what I did and just Google practice problems for redox reactions. That's why I have a hard enough time coming up with practice problems for regular reactions, let alone for redox reactions. So just redox reaction problems, and you'll get all sorts of these things, as well as offers of help. So that's how I recommend that you get more practice. But definite. Oh, you couldn't see any of that, could you? You might have been able to see some of it. Let's see. I can bring it back up easily enough. So let's go Control-Shift-T and bring that up. And now we'll close this guy. Now you can see what I'm looking at. All right. Just practice redox reaction problems or redox reaction practice, things like that. And there will be tons and tons, because we absolutely know and understand how difficult these things are. I really strongly recommend you spend a lot of time practicing these. They will cause you a lot of grief. It's really easy to make mistakes. And I really definitely recommend you write down every little bit of scrap of stuff that you have when you're doing this. Keep notes of all the changes that you make as you make them. I save myself time and space, because the thing is, when you're writing with these stupid Sharpies, they're really broad tipped, and my page would just become a helpless mess if I tried to write down as much as you should be writing down. You should also get multicolored pens. Okay, so that is it for tonight. I've also already, I've got the stuff left over from the spring, so go ahead and watch those 4 videos as well. oxidation numbers, and redox reactions. Okay, I will see you around.